Welcome back, Chemistry 30. This is the new section, EQ3, also dealing with chemical equilibria, but this time we look at observe and analyze phenomena related to acid-base reactions in equilibrium. So EQ1 was just simply introduction to equilibrium, Le Chatelier's principle, etc. Then EQ2, we looked at solubility equilibria, the equilibrium between a solute and a solution. And now we look at how it's applied to acids and bases. So these are the sections we'll be looking at here. And this video deals with the first one, a very quick section, also a very easy assignment, just simply a brief review of acids and bases. So if you look at the first page here, EQ3.1, a brief review, define their Arrhenius definition of acids and bases. So from the earliest days of experimental chemistry, scientists have recognized acids and bases by their characteristic properties. So some things that you've likely have taken earlier in earlier science courses. Acids have a sour taste. They cause certain dyes to change color, such as litmus paper. Causes litmus paper to turn pink or red. Whereas bases tend to have a bitter taste and feel slippery. And they also cause indicators to change as well. For example, litmus to change blue. When acids and bases are mixed together in certain proportions, their characteristic properties disappear altogether. So for example, if we have an acid and a base, it can become neutralized and make a salt and a water. And we'll look at that towards the end of this section. And by 1830, it was evident that all acids contain hydrogen, but not all hydrogen containing substances are acids. During the 1880s, the Swedish chemist Svante Arrhenius defined acids as substances that produce hydrogen ions, H+, or otherwise known as H+, in water, and bases are substances that produce hydroxide ions, or OH- ions in solution. Over time, Arrhenius' concept of acids and bases came to be stated the following way. So, put a little star here. So an acid is something that when dissolved in water, it increases the amount of H+ there because the acid is made up of that. A base, a substance that when dissolved in water, increases how much OH- ions there are because bases have OH- ions, according to Arrhenius. So an aqueous solution of HCl, hydrochloric acid, it is an Arrhenius acid because when it breaks down, it releases H+ ions in solution. Sodium hydroxide is an Arrhenius base because, as you notice, yes, it increases the amount of OHs in there because it consists of OH- ions itself. Hey, that's it for the introduction to acids and bases using their Arrhenius definition. In the next video, we'll look at Bronsted-Lowry definitions, but for this, we'll stop there with that, and you'll be able to do the assignment 3.1. All right, we'll see you again.